This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at change of variables, polar coordinates. And let's take a look at our first problem here. So this goes from 0 to pi, and that's theta. So theta is equal to 0 to theta is equal to pi, and r is equal to 0 to r is equal to sine theta of r dr d theta. And it says evaluate the double integral. So nothing special here, just different variables, but what we've seen in the past. So we'll work with the inner integral first. So theta is equal to 0 to theta is equal to pi carries down. The integral of r is 1/2 r squared from r is equal to 0 to r is equal to sine theta d theta. Now the 1/2 I can put out in front, so I don't have to worry about it. And then let's plug in these. So I'll plug in the sine theta for r. So we're going to have sine theta squared minus, and I'll plug 0 in for r. So we'll have 0 squared d theta, which gives us 1/2 theta is equal to 0 to pi. The 0 squared drops away, and we end up with sine squared d theta. Now we got from trig we got an identity that says sine squared. Write that a little bit cleaner. Sine squared is equal to 1 minus cosine 2 theta over 2. So this sine squared here, we can replace that. So theta is equal to 0 to theta is equal to pi. We can replace that with 1 minus cosine 2 theta over 2 d theta. Now the 2 you see right here, that's like 1/2. We can take that and put it out in front. So we'll have 1/2 times 1/2. Theta is equal to 0 to theta is equal to pi of 1 minus cosine 2 theta d theta. And that gives us 1/4. And let's go ahead and split these into two separate integrals now. So we're going to have the integral from theta is equal to 0 to theta is equal to pi of 1 d theta minus theta is equal to 0 to theta is equal to pi of cosine 2 theta d theta. Well, this first one, the integral of 1 is just 1 theta or theta. So we're going to have theta from 0 to pi. And over here, if we do the u substitution, we let u equal to 2 theta, then du will equal 2 d theta. So we need a 2 inside, and we'll offset with a 1/2 out in front. So we got minus 1/2, like that. And we got cosine 2 theta, and then we got 2 d theta. We only got 1/4, and I'll plug pi in for theta. So we got theta minus, and I'll put 0 in for theta, and minus 1/2, and this becomes theta is equal to 0 to theta is equal to pi of cosine u, and then we're replacing the 2 d theta with du. So that gives us 1/4 pi minus 1/2 And the integral of cosine is sine u. Theta is equal to 0. Theta is equal to pi. And so we got 1/4 pi minus 1/2. And we'll plug the u back in. Up above we said u is equal to 2 theta. So we're going to have sine of 2 theta from theta is equal to 0 to theta is equal to pi equals 1/4 pi minus 1/2. We'll plug theta, or plug pi in for theta. So we've got sine of 2 pi minus sine of 2, and they'll put 0 in for theta. So 2 times 0. Which gives us 1/4 pi minus 1/2. Sine of 2 pi, if I look that up in a circle, that's 0. Minus 2 times 0 is 0, and sine of 0 is 0. Well, 0 minus 0 is 0, times 1/2 is 0, so that drops away. And we got 1/4 times pi, which gives us pi over 4 for our answer. Let me save this. Change the variables, polar coordinates. There we go. Calc 3. Change of variables, polar coordinates. Page 01.pdf. Okay, let's look at our second problem here. This is just another evaluate. So we're going to have theta is equal to 0 to theta is equal to pi over 2. And r is equal to 0 to r is equal to 4. Of r squared cosine theta dr d theta. So do the inner one here first. Well, the cosine theta is the constant portion, so I'll just carry it along. But the r squared is what we're working with, because we're taking the integral with respect to r. So it becomes 1/3 r to the third cosine theta from r is equal to 0 to r is equal to 4. Now the 1/3 I can put completely out in front, so I'll go ahead and do that. Theta is equal to 0 to theta is equal to pi over 2. Now I'm going to plug the 4 in for the r. So we're going to have 4 to the third cosine theta minus, now put 0 in for the r. So we'll have 0 to the third cosine theta d theta. Well, 0 to the third is 0 times cosine is 0, so that drops away. 4 to the third. 4 times 4 is 16, times the other 4 is 64, so I'll take it out in front. So I have 1/3 times 64. Theta is equal to 0 to theta is equal to pi over 2 of cosine theta d theta. Which gives us 64 thirds. The integral of cosine is sine. And that'll go from theta is equal to 0 to theta is equal to pi over 2. If I plug in those values, I put pi over 2 in for theta, I get sine of pi over 2 minus sine, and if I put 0 in for theta, sine 0. Well, if I look at my unit circle, sine of pi over 2 is 1, minus sine of 0 is 0. Which gives us 1 minus 0, which is 1, which gives us 64 thirds as our answer. Let me go ahead and save that. And next one's another evaluate. So the outer one is theta again. So theta is equal to 0. Theta is equal to pi. The inner one's r. R is equal to 0. To r is equal to 2. The reason I know that is because dr is inside, so this inner one is r's. And the d theta is on the outside, so the outer one's your thetas. I find you have less mistakes if you actually write it in this form. And then the square root of 4 minus r squared dr d theta. Well, I'll do the inner one first. If we look u equal to what's inside the radical, we got u is equal to 4 minus r squared. Du, the 4 goes away, derivative of negative r squared is negative 2r dr. So then this becomes theta is equal to 0 to theta is equal to pi. I'll leave these in terms of r's. Some people like to switch them to u's, but that's up to you. And actually, I need to put some stuff in here first, don't I? I need a negative 2 in there, so I'll offset with a negative 1/2 out in front. Like that. And I'm going to go ahead and write this as 4 minus r squared to the 1/2 power. dr d theta. Okay. Now I'm going to go ahead and put that negative 1/2 clear out in front. And this now becomes, this is till r is equal to 0, to r is equal to 2. And 4 minus r squared becomes u, so this is u to the 1/2. Negative 2r dr gets replaced by du. And d theta. Well, we're going to do the inner integral first. So I got negative 1/2. Theta is equal to 0 to theta is equal to pi. Add 1 to our power, divide by our new power. So it gives us 2/3 u to the 3/2 from r is equal to 0 to r is equal to 2 d theta. Now let's plug our u back in. Up here we said u is equal to 4 minus r squared. So we'll plug that back in. The 2/3 actually I could put clear out in front. I don't know why I'm not leaving room enough for that, but let's try it again. Negative 1/2, and I'll put the 2/3 clear out here. So we're left with u to the 3/2. So the u gets replaced again by 4 minus r squared to the 3/2 from r is equal to 0 to r is equal to 2 d theta. Well, the 2's cancel here, so this we end up with a negative 1/3 out in front. Theta is equal to 0 to theta is equal to pi. And we'll plug in our 2 for our r, so we're going to have 4 minus 2 squared to the 3/2 power minus 4 minus, and we'll put 0 in for the r. So 0 squared to the 3/2 d theta. So we got negative 1/3. Theta is equal to 0. Theta is equal to pi. Now 2 squared is 4, so we have 4 minus 4, that gives us 0, and 0 to the 3/2 power drops away. And this negative carries along. That 0 squared drops away, so we got 4 to the 3/2 power. D theta. Well, I can take that and put it out in front, but let's first examine what 4 to the 3/2 power is. If I come up here, this is from intermediate algebra. If you have a number to a fractional power where your numerator is greater than 1, we got a property that says you can take the number up on top, the numerator, the 3, put it on the outside of the parentheses. So we can rewrite this as 4 to the 1/2 power raised to the 3rd power. We can rewrite what's inside the parentheses in radical form. So that's the square root of 4. Square root of 4 gives us 2, so we got 2 to the 3rd, which gives us 8. So 4 to the 3/2 is equal to 8. So this becomes negative 1/3. Theta is equal to 0 to theta is equal to pi. of -8 d theta. Well, the -8 I could put clear out in front, so that gives us 8/3. Theta is equal to 0 to theta is equal to pi of d theta. Now, if there was something in here, it'd be an invisible 1. So the integral of 1 is theta, 1 theta or theta, from theta is equal to 0 to theta is equal to pi. 8/3 remains out in front. We'll plug pi in for theta, so we got pi minus, and we'll plug 0 in for theta. So we got pi minus 0, which is pi, which gives us 8 pi over 3. And that's our answer. Let me go ahead and save that. And let's look at our next problem. Actually, I guess we need to look at a formula first. Theorem. We'll grab a drink. Now, this is a change of variables to polar form. Sometimes you may find it easier to switch it from rectangular, or x's and y's, to r's and thetas, polar form, to find the integral. Sometimes you have to. You can't solve the problem when it's in rectangular. It says let R be a plane region consisting of all points where xy is equal to r cosine theta, r sine theta. And we already know that. X is equal to r cosine theta, y is equal to r sine theta. Satisfying the conditions that 0 is less than or equal to g sub 1 of theta, is less than or equal to r, is less than or equal to g sub 2 of theta, and alpha is less than or equal to theta, is less than or equal to beta, where 0 is less than or equal to beta minus alpha, is less than or equal to 2 pi. If g sub 1 and g sub 2 are continuous on alpha to beta, and f is continuous in r, then we can use this following formula to rewrite it. The formula makes it kind of complex. It's not too tough of a concept. You'll probably find it easier to put your r's on your inner integral and your thetas on your outer integral. Well, let's take a look at a problem dealing with this and see how it works. So we got the outer one, which is, see the dx, so these are x values. So we got x is equal to -3 to x is equal to +3. And the inner ones are y's, so we got y is equal to 0 to y is equal to square root of 9 minus x squared. And then x squared plus y squared dy dx. Now, if we looked at the graph of this, -3 to +3, 2, 3, 1, 2, 3, and y is equal to square root of 9 minus x squared. Now, y is equal to square root of 9 minus x squared is a half a circle, and we're going from -3 to +3. A lot of times you can look at this and kind of see the setup, because it just kind of makes sense. Like if we looked at our r first, we put r equals 0 here, so that would be the starting place here, and then if I go out this distance, that would be r is equal to 3. Angle-wise, if I started with this angle right here, this is theta is equal to 0. And then if I were to go over to this angle right here, that angle would be pi. So we got theta is equal to pi. So a lot of times you can look at these and kind of see how they go. If we looked at the y equals 0 here, Well, we know y is r sine theta, so you have r sine theta is equal to 0. Now these won't always work out like you might think. The picture is invaluable for this. Theta is equal to pi there, where that goes over like that. Okay, so if we divide both sides by sine theta, we'd get r is equal to 0, which kind of makes sense from that. Now, this right here, y is equal to square root of that. Well, if I were to square both sides, we'd have y squared is equal to 9 minus x squared, and I take the negative x squared over, and we get x squared plus y squared is equal to 9. And we know that r squared is equal to x squared plus y squared. So we got r squared is equal to 9. And then r is going to equal to plus or minus square root of 9. Or r is equal to 3. Now I don't worry about the minus, because if I go from 0 to pi, it'll encompass this entire area right here. In terms of our region of integration. When you throw the instructions here, evaluate to iterate and go by, well, we're going to see later on we're dealing with volume. But when we're talking about just the area of integration here, it's just x's and y's. Now if we might be able to do this different, where we have r is equal to plus or minus 3, but how in the world would you set that up? It makes it harder. So it's best to go from 0 to pi and just have it go from r is equal to 0 to r is equal to 3. Now the outer ones here aren't so easy to get. They don't flow like you think. It's best to look at your picture and kind of come up with that. But you definitely get these inner ones. And it's pretty easy once you see the setup. Here's y is equal to 0, r is equal to 0, and this is a circle of radius 3, so this has to be r is equal to 3. Okay, now we already said that r squared is equal to x squared plus y squared, so we can replace this with r squared. Now our formula says we have to have an additional r on here, so that's what that is. So we have to put an r on there. Now I'm real bad about forgetting that. So then this becomes theta is equal to 0, theta is equal to pi, r is equal to 0 to r is equal to 3, and r squared times r is r to the third, dr d theta. Well, we'll do our inner integral. So this is still theta is equal to 0 to theta is equal to pi, and that gives us 1/4 r to the fourth. You add 1 to your power, divide by your new power, from r is equal to 0 to r is equal to 3 d theta. Well, we can take the 1/4 and put it out in front, so we don't have to worry about it. Theta is equal to 0 to theta is equal to pi. And now we'll plug these numbers in for the r. So we got 3 to the 4th minus 0 to the 4th d theta. Well, 0 to the 4th drops away. 3 to the 4th is 81, and we can take the 81 and put it out in front. So we got 1/4 times 81. Theta is equal to 0. Theta is equal to pi of d theta. Gives us 81/4. There's an invisible 1 in here, so the integral of 1 is theta. From theta is equal to 0 to theta is equal to pi. Well, now if we plug those in, we'll plug in the pi for theta, minus, and plug 0 in for theta. And the 0 drops away, and we end up with 81 pi over 4 as our answer. Now there are certain times where this setup works very well, and you'll get used to that, where you have like a square root of a number minus x squared type of deal. That works perfect for, because it's a circle already. There's other times too, but those are probably the ones you run across most in books. So let me get and say that. Excuse me. Mean to. Didn't mean to burp right in the. A little bit too much to eat, I think. Made my veggie surprise for dinner. Potatoes and onions and peppers. I had jalapeno. I had poblano. Oh, it was good. Had mushrooms in it. I can only make that when my wife's not here. She can't stand that smell because I get the house smelling pretty good of onions and peppers and all that. Okay, our other one is x. So we got x is equal to 0. X is equal to 1. And we got y is equal to 0. Y is equal to square root of 1 minus x squared. And then we got x squared plus y squared to the 5 halves dy dx. Now let's look at the picture of it first. And from the picture it'll be pretty obvious the setup. X is equals 0 to x equals 1. Then this is normally a half circle of radius 1. But since we're only looking from x equals 0 to x equals 1, we're only looking at this piece right here. So this is what we're dealing with. Okay, well, r is equal to 0 to r is equal to 1. Again, r is equal to 0 is the origin here, r is equal to 1 goes out to here, and then my angle goes from 0 to pi over 2, because this right up here is pi over 2. So this will be theta is equal to 0, the theta is equal to pi over 2. Now, we've already said that x squared plus y squared is equal to r squared, so we're going to have r squared to the 5 halves power, and then we have to have an r to the side. dr d theta. Okay, so theta is equal to 0, theta is equal to pi over 2, r is equal to 0, r is equal to 1. Now, when we raise 2 to the 5 halves power, the 2 is going to cancel, and we have r to the 5th times r, dr d theta. So then we got theta is equal to 0 to theta is equal to pi over 2. R is equal to 0 to r is equal to 1. R to the 5th times r gives us r to the 6th. dr d theta. Going to handle the integral here. So we got theta is equal to 0. Theta is equal to pi over 2. And add 1 to our power, divide by our new power. So that gives us 1/7 r to the 7th. From r is equal to 0 to r is equal to 1, d theta. Well, now we can plug in our values. The 1/7 I'm going to go ahead and put clear out in front. Again, numbers you can freely take in and out. Theta is equal to 0 to theta is equal to pi over 2. And we got r to the 7th. So we'll plug 1 in for r. So we're going to have 1 to the 7th minus, and we'll plug 0 in for the r. So 0 to the 7th. d theta. Well, 0 to the 7th drops away. 1 to the 7th is 1. So this becomes 1/7 integral from theta is equal to 0 to theta is equal to pi over 2 of d theta. Well, like I said, there's an invisible 1 in here. So this is going to become 1. The integral of 1 is 1 theta or theta. From theta is equal to 0 to theta is equal to pi over 2. Well, now we'll plug those in. So I got 1/7, and I'll plug pi over 2 in for theta. So I got pi over 2 minus, I'll plug 0 in for theta. Well, that 0 drops away, and 1 times pi is pi, and 7 times 2 gives us 14. And that's our answer. So let me go ahead and save that. And let's take a look at our next problem. This one goes from -3 to 3, and what are those? Probably my x values. Let's try that again. -3 to 3, and those are, yeah, my outer one's dx, so these are x values. And so these will be y values. Y is equal to 0. To y is equal to square root of 9 minus x squared. Cosine of the square root of x squared plus y squared dy dx. Well, we want to change it to polar. Negative 3 to 3. Well, here's negative 3. And here's 3. That's my x values. And this is, again, a half circle of radius 3. So this is what we're working with. And again, you're probably going to get very used to these. R is equal to 0 to R is equal to 3. And then theta. Well, it's pretty obvious it goes from 0 to pi. Because again, we start here and then it goes over to here, which is pi. And we got cosine and square root. X squared plus y squared is r squared. And then we have to have an extra r here. dr d theta. Okay, so that's going to give us theta is equal to 0 to theta is equal to pi of r is equal to 0 to r is equal to 3. The square root of r squared becomes r. So, and this r I'll put out in front. So we're going to have r cosine theta of r. dr d theta. We want to handle the inner one. And the easiest way to do this is by parts. So come over here. Learn to write more legible. Try it again. So the derivative column, that's going to be the r, because it'll disappear if I keep taking derivative of it. Well, the derivative of r is 1, and derivative of 1 is 0. Signs, this starts at plus, goes to minus, goes to plus. And for our integral, this would be cosine r. And the integral of cosine r gives us sine r. And then the integral of sine r gives us negative cosine r. And this is the flow. So let's see what we got. We got theta is equal to 0 to theta is equal to pi. And then this becomes a positive r times sine r. So that's r sine r. And then we got a negative 1 times a negative cosine, which gives us a positive cosine r. From r is equal to 0 to r is equal to 3. d theta. Well, theta is equal to 0, theta is equal to pi. We'll plug 3 in for r, so we're going to have 3 sine 3 plus cosine 3 minus, I'll put parentheses because that's the flip side of everything that follows it, and I'll put 0 in for r. So I got 0 sine 0 plus cosine 0 d theta. So we're going to have theta is equal to 0 to theta is equal to pi. And we'll have 3 sine 3 plus cosine 3. Now 0 times sine 0 drops away. Cosine of 0 is 1. So that gives us a negative 1. Let me think about that. So I got 3 sine 3 plus... Yeah, that's right. Okay, never mind. I had a mental lapse there. Now notice what's inside there doesn't have any kind of thetas at all. So that's a constant. So we could actually go ahead and put that out in front. So we got 3 sine 3 plus cosine 3. It just seems so weird what I came up with. And then this will be theta is equal to 0 to theta is equal to pi d theta. Well, there's always an invisible 1 left in here, and then the integral of 1 is theta. So this becomes 3 sine 3 plus cosine 3 minus 1, and then theta, from theta is equal to 0 to theta is equal to pi. which gives us 3 sine 3 plus cosine 3 minus 1. And we'll plug pi in for theta. So we've got pi minus, and put 0 in for theta, which then gives us, I'll put the pi out in front, pi times 3 sine 3 plus cosine 3 minus 1. And that's our answer. Let me go ahead and save that. Okay, now where all this is leading to is, I think I got the wrong instructions there. But we're trying to find the volume. So we got f of xy is equal to x plus y. So we've got a three-dimensional object here, but it's bounded. R is our region of integration. We're taking a look where x squared plus y squared is less than or equal to 16. X is greater than or equal to 0. And y is greater than or equal to 0. So again, we're finding the volume here. Now, this is just a plane, but again, when you start throwing all these other bounds in here, then it becomes three-dimensional. Or I should say a three-dimensional. Plane is just flat, but when you add that all these bounds into, it becomes a three-dimensional solid. Okay. Well, x squared plus y squared is less than or equal to 16. That's a circle. Well, our x squared plus y squared is equal to 16 is a circle of radius 4. And then when you say less than or equal to 16, that means we go from 4 into 0. And x is greater than or equal to 0, y is greater than or equal to 0. So what we're looking at, here's our x, here's our y. We're looking at this piece right here. So that's our region of integration. And it's just not the line here because it's less than or equal to 16, so it includes all of this. Well, let's do our setup. And we've seen enough of these, I think you're probably getting it. R is equal to 0 to R is equal to 4. Again, because our radius is 4. And this will go from theta is equal to 0 to theta is equal to pi over 2. Because it only goes up to here. It doesn't go all the way over here. And then we have x plus y in the middle. But x plus y, remember x is equal to r cosine theta, and y is equal to r sine theta. So this one right here, we replace the x with r cosine theta, plus y is r sine theta. And when we're converting to polar, we have to add that extra r in there, dr d theta. And that's going to be the integral we're going to work with. Okay. So we got theta is equal to 0, theta is equal to pi over 2, r is equal to 0, r is equal to 4. Now these r cosine theta plus r sine theta, they both have an r in common, so I can factor that out. When I factor that out, I can multiply times the r that's already there. So that gives us r squared times cosine theta plus sine theta, dr d theta. Well, we'll do the inner integral first. The cosine theta plus sine theta doesn't have any r's in it, so that's like the constant portion when we're taking the integral with respect to r. So the integral of r squared gives us 1/3 r to the third. And then cosine theta plus sine theta from r is equal to 0 to r is equal to 4 d theta. Well, I can take the 1/3 and put it clear out in front. So I got 1/3 theta is equal to 0 to theta is equal to pi over 2. And I could even put the cosine theta plus sine theta, not clear out in front, but out in front of the brackets there. So we've got cosine theta plus sine theta. R to the third from r is equal to 0 to r is equal to 4. D theta. This gives us 1/3. Theta is equal to 0 to theta is equal to pi over 2. Cosine theta plus sine theta. Put 4 in for r, so I get 4 to the third minus, put 0 in for r, so 0 to the third, d theta. Now 0 to the third drops away. 4 to the third is 64, and I'll go ahead and put it clear out in front. So we're going to have 1/3 times 64. Theta is equal to 0. Theta is equal to pi over 2 of cosine theta plus sine theta d theta, which gives us 64/3. The integral of cosine is sine. The integral of sine is negative cosine. So that becomes sine theta minus cosine theta from theta is equal to 0 to theta is equal to pi over 2. And now I'll plug in those values. So I'm going to first put pi over 2 in for theta. So I have sine of pi over 2 minus cosine of pi over 2 minus, I have to put parentheses here because it affects everything that follows it. I'll put 0 in for theta. So we've got sine 0 minus cosine 0. So that gives us 64/3. Sine of pi over 2 is 1. Minus cosine of pi over 2 is 0, if you look in a unit circle. Minus sine of 0 is 0. Minus cosine of 0 is 1. Well, this 0 drops away. Here we got a minus minus, so that becomes a plus 1. So we got 1 plus 1, which is 2, which gives us 128/3. And that's our answer. Let me go ahead and save that. And again, what we're finding there is the volume. Okay, let's look at another volume one. We've got z is equal to 3xy, and x squared plus y squared is equal to 4, and it's in our first octant. And it says use the double integral and polar coordinates to find the volume of the solid bounded by the graphs of the equation. Now here they don't give us a setup for r like the previous one did. The previous one told us exactly how to set up our region of integration. This one doesn't. But if we think about it, we have this, which is a plane, and it's bounded by this, and we're dealing with the first octant. Volume implies that we're not dealing with a hollow object, so it's solid inside. It even says volume of the solid. So this is actually going to be less than or equal to 4 when we think about it. First octant. Well, that means your x and your y values are both positive. So in r would be 2. So we're looking at this little half circle right here. So that's going to be our setup. So let me go ahead and put, I'm going to put it directly into polar. So we got r is equal to 0 to r is equal to 2. And theta starts at 0. And theta goes to pi over 2. Again, it doesn't go clear over here, so it doesn't go to pi. It stops right here, which is pi over 2. And we got 3xy. So 3 is there. Now remember what x is equal to. X is equal to r cosine theta, and y is equal to r sine theta. So we're going to replace the x with r cosine theta, and we'll replace the y with r sine theta. And then we need the extra r in there, because we changed it to polar. dr d theta. So let's see what we got. Theta is equal to 0. Theta is equal to pi over 2. Actually, there's 3 I can put clear out in front. And then r is equal to 0 to r is equal to 2. And we have an r here, we have an r here, and we have an r here. So we got r to the third, cosine theta, sine theta, dr d theta. Okay, so work with our inner integral first. Now cosine theta and sine theta would be considered a constant when we're integrating with respect to r. So theta is equal to 0, theta is equal to pi over 2. The integral of r to the third, add 1 new power divided by new power. So we got 1/4 r to the fourth, cosine theta, sine theta, from r is equal to 0 to r is equal to 2, d theta. Now the 1/4 I can put clear out in front. The cosine theta, sine theta I can put out in front of the brackets. So we got cosine theta, sine theta, and then we got r to the fourth from r is equal to 0 to r is equal to 2, d theta. Well, that gives us 3/4. Theta is equal to 0, theta is equal to pi over 2 of cosine theta, sine theta. And we'll plug in these values for r. So put 2 in for r, so we've got 2 to the fourth, minus, and put 0 in for r, we've got 0 to the fourth, d theta. Well, 0 to the fourth drops away. 2 to the fourth gives us 16, and I can put it clear out in front. So we've got 3/4 times 16. Theta is equal to 0 to theta is equal to pi over 2. Cosine theta, sine theta, d theta. Well, this is a perfect u substitution. If we let u equal to sine theta, du, the derivative of sine is cosine. So we'll have cosine theta, d theta, which we already have the cosine theta, we already have the d theta. So this becomes 4 into 16 gives us 4, so that gives us 12. And then this becomes theta is equal to 0, theta to pi over 2. And sine theta gets replaced by u, cosine theta d theta gets replaced by du. Well, the integral of u is 1/2 u squared. Theta is equal to 0. Theta is equal to pi over 2. I'll take the 1/2 and put it out in front. So we got 12 times 1/2. And for the u squared, I'll plug my u equals back in. I said u is equal to sine theta. So this will become sine squared theta. From theta is equal to 0 to theta is equal to pi over 2. And I guess I better continue up here. 12 times 1/2 gives us 6. And we'll plug these in for theta. So I'm going to have sine squared of pi over 2 minus sine squared of 0. Well, sine of pi over 2 is 1, so that becomes 1 squared minus sine of 0 is 0, so that's 0 squared. Now 0 squared drops away. 1 squared is 1 times 6 would give us 6. And that's our answer. So I'm going to go ahead and save that. And that looks like our last problem. So I'm going to go ahead and stop the recorder too.